Hello, statistics and pre-calculus. As you're preparing for the exam, a little bit on p-values and hypothesis testing, as you asked. Just a quick review of statistical significance and the overall picture. The real question that you're asking is, how likely is it that I got my results just by random chance? Because things do happen at random that you don't expect. You can never really rule out the fact that it could be random. You could flip 10 straight coins and get 10 straight heads. The chances are about 1 in 1,000, so it's very unlikely, but it's possible. If everybody in the school did it, if every person in prime, middle, and upper, and all the employees did it, 1 or 2 people would be likely to get 10 straight heads, even with a good coin. So your plan is, assume there's no underlying difference. That's your null hypothesis. And then if your final result would be very unlikely if there's no underlying difference, your null hypothesis is probably wrong. This is the U.S. government, the U.S. legal system, the way it's supposed to work. You're supposed to assume that people are innocent until you prove them guilty beyond a reasonable doubt. And so statistically, the question is, what is a reasonable doubt? We're assuming innocent until we prove beyond a reasonable doubt. So we need a p-value for this. A p-value is the probability that the data would be at least as extreme as those observed if the null hypothesis were true. What is the p-value? There are different ranges. How unlikely counts as very unlikely. If you're talking about a value of more than 10%, that is not a statistically significant result. That is something that happens pretty regularly. You would not count that as unusual. If something's between 5 and 10%, it's marginally significant. It might be something that you would call a legitimate statistical significant result if you've got something that's a low priority, something that you're not terribly worried about, where the downside is not a big deal. If you're between 1% and 5%, then you start to get into statistically significant results. And you're saying, okay, this happens, less than 5% of the time. So, the fact that it came up means it's likely that there is something going on here. Of course, that means you're going to be wrong 5% of the time. And statisticians, accept that might happen. If you're less than 1%, the result is highly significant. You reject the null hypothesis, you're all good. So here's a quick instinct one. Flip a coin, is it fair? You flip it 10 times, you got 6 heads, 4 tails. Is that a fair coin? You don't know. You flip it 100 times and get 60 heads, 40 tails. What about that? Is that fair or not? You don't know. What about 1,000 flips, 600 heads, 400 tails? In both cases, this is 60% heads. 60% heads, 60% heads. But your intuition probably tells you that under the third scenario, it's much less likely that the coin is fair, much more likely that it comes up heads more often than tails. And so you do, in fact, you run these. 6 heads, 4 tails, that's not unusual at all. If you flip 9 coins, the most equal you can get is 5 heads, 4 tails, or 4 heads, 5 tails, so 4 and 5, and then you even have a 50% shot of getting there. Anyway, so if you run some statistical tests, not on the exam, you would get a p-value of 0.52. A p-value of 0.52 for this experiment, which means 52% of the time you would get something that's at least this unusual, at least this far off from 50%. So half the time. No, that's not an unusual result at all. You cannot conclude anything about that coin. However, if you flip it 100 times and get 60 heads, 40 tails, you get a p-value of 0.0455, which means this is going to happen about 4.5% of the time. How unusual is that? 4.5% of the time. It'll happen, just from a random coin. But a statistician would say, that's less than 5%. I'm going to reject the null hypothesis that the coin is fair, and I'm going to conclude the coin is not fair. So we do that. You have a statistically significant result. Here, we do this, and we have p is 2.55 times 10 to the negative 10th. Also known as 0.000000000255. So, yes, there's a minuscule chance that you could flip a fair coin 1,000 times and get 600 heads. But it's so ridiculously unlikely. No. That counts as a highly significant result. A statistician would be 100% confident in saying, well, 99.999999999% confident in saying that the coin is not fair. It's not a 50-50 coin. So again, going back to your p-values, you're looking at this. More than 10%, not significant. Between 5 and 10%, marginally significant. Excuse me. Between 1 and 5%, statistically significant, and less than 1%, highly significant. So there you go. That's how sure you are that something is not the case. That's how sure you are that somebody is guilty. You would not send them to jail if you think there's if the chance of them being innocent is more than 10%. If the chance of them being innocent is less than 1%, maybe you would. There we go. End